Hello grade 6, welcome back to our online class. In this video, we're going to talk about word problems involving simple algebra. Remember, when you were in grade 5, grade 4, or even in grade 3, you were taught how to use models as an approach in solving word problems. Let's have the following word problems. Number 1, Lawrence has Y books. John has 3 times as many books as Lawrence. John buys another 7 books. Again, if you can't understand the word problem in just one reading, then you have to read that problem again. And don't forget to spot or to find keywords because the keywords will help you understand, will help you answer the question of the problem. The problem says Lawrence has Y books. John has 3 times as many books as Lawrence. So we have this model for John. And John buys another 7 books. So we add 7 more books to John's model. How many more books does John have than Lawrence? That's question letter A. We're looking for the difference between the number of books John has and the number of books Lawrence has. In the model, John has 3y plus 7 books, right? So to answer question letter A, we're going to subtract 3y plus 7 and y. And remember, when you simplify algebraic expression, you have to make sure first that similar terms are placed side by side. That is, 3y plus 7 minus y becomes 3y minus y plus 7. And 3y minus y simplifies to 2y, and you still have plus 7. What does 2y plus 7 mean? It means that John has 2y plus 7 more books than Lawrence. You can also find that answer or get that answer right away from the model. The question in letter A, how many more books does John have than Lawrence? You're actually looking for this value. This is question mark, and this is the one we're looking for in letter A. Okay, so it's just very easy to use the model to answer letter A. So John has 2y plus 7 more books than Lawrence. Letter B. If Lawrence has 25 books, Lawrence has y books in the beginning. Therefore, if Lawrence has 25 books, then the value of y is 25. How many more books does John have than Lawrence? John has 2y plus 7 more books than Lawrence, and the value of y is 25. Then we're just going to replace y with 25. So we have now 2 times 25 plus 7. And 2 times 25 simplifies to 50 plus 7. 50 plus 7 is 57. Therefore, John has 57 more books than Lawrence if Lawrence has 25 books. Okay? Problem number 2. Charlene has X dollars. She bought a dress for $35 and spent the rest of her money on 3 identical notebooks. There's only one person involved in the problem, so we're just going to make one bar model, and that bar model is for Charlene alone. Okay, the problem says that Charlene has X dollars. She bought a dress for $35. So the question here is, where is $35 coming from? You should be able to recognize that the $35 is coming from X dollars. In other words, we're going to take away $35 from X. So the model now becomes like this. And the remaining amount is X minus 35. This is the amount spent on 3 identical notebooks. Since Charlene spent this remaining amount on 3 identical notebooks, then we're going to divide the remaining portion of the model into 3 equal parts. So to find the price of one notebook in terms of X, we are going to divide X minus $35 by 3, or this is the same as X minus 35 over $3. This is our answer for letter A. Letter B, if Charlene had $50, it means the value of X is $50. What was the price of one notebook? The price of one notebook, as stated in letter A, it's X minus 35 over $3. And the value of X given in question letter B is 50. So we evaluate this expression at X equals 50. We replace X with 50. We have now 50 minus 35 over 3. And 50 minus 35 simplifies to 15. And we still have the denominator 3. 15 over 3 is equal to 5. Therefore, the price of one notebook was $5 when or if Charlene had $50. Problem number 3. Rani and Lisa bake 42 muffins altogether. Rani baked 16 more muffins than Lisa. How many muffins did Lisa bake? There are 2 people involved in the problem, Rani and Lisa. What we know about them is that Rani baked 16 more muffins than Lisa. So if we let X to be the number of muffins baked by Lisa, then the number of muffins baked by Rani is going to be X and 16 more. Okay? The problem says that Rani and Lisa baked 42 muffins altogether. So altogether, we have a total of 42 muffins. The question here is, how many muffins did Lisa bake? So our question mark is this one. We're looking for the number of muffins baked by Lisa. Okay? In other words, we're looking for the value of 1x. We're looking for the value of 1x. Now, look at this model. If I'm going to take away 16 or remove 16, I'm also going to take away 16 from 42, right? If I'm going to take or remove 16 from this model, I'm also going to remove 16 from the total 42. This means that 2x is the same as 42 minus 16. And 42 minus 16 simplifies to 26. And grade 6, 2x equals 26 is an example of an algebraic equation because we already have here an equal sign. 2x is an algebraic expression. 26 is another expression, and you are going to equate them using this equal sign. Therefore, 2x equals 26 is an algebraic equation. Okay? Now, 2x is 26. 2x's is 26. So if we want to find 1x, we're going to divide 26 by 2. And 26 divided by 2 simplifies to 13. Therefore, the value of 1x is 13. That means Lisa baked 13 muffins. Problem number 4, and this is going to be our last example. A mother is now 3 times as old as her son. If the sum of their ages is 48 years, how old is the son? The problem involved 2 people, mother and her son. We let Z to be the age of the son. And the problem says that the mother is 3 times as old as the son. So the model to represent mother's age is going to be like this. 3 times the son. Okay? If the sum of their ages is 48, it means altogether the total of their ages is 48. How old is the son? We're looking for this one. We're looking for the value of 1z. If we're going to look at the model, 1, 2, 3, 4z equals 48, right? 4z equals 48 is another example of algebraic equation. Now, our goal is just to look for the value of 1z. So if we want to find 1z, we're going to divide 48 by 4. And 48 divided by 4 is 12. Therefore, the age of the son is 12. Okay? I hope you learned something from this video. And if you still have more questions or clarifications, you may ask them during our Zoom sessions. That's all for today, and see you in my next videos.